Welcome to solverfy.
Hi, in the given problem, we are having a combination of two lenses. The first one is a converging lens of focal length f1, and the second one is a diverging lens of focal length f2, where the values of the focal lengths are, for f1, this is plus 30.0 centimeter, and for f2 this is minus 20.0 centimeter. The height of the object, an object has been kept to the left of this converging lens. The height of this object HO has been given as 2.00 centimeter, and the distance of this object from the converging lens has been given as P1 is equal to minus 40.0 centimeter. The magnitude of this distance is 40 centimeter, and for sign convention we have taken the negative sign, minus 40 centimeter. Now we have to obtain the final position of the image formed by this combination. The gap between the two lenses has been given as 110 centimeter. Now first of all, to find the position of the final image, first we consider the converging lens. So for converging lens, the distance P1 is equal to minus 40.0 centimeter. The focal length F1 is plus 30.0 centimeter. So using thin lens formula, one by Q1 minus 1 by P1, where Q is the distance of image from the lens, is equal to 1 by F1. So putting the known values, Q1 is unknown, minus 1 by minus 40 is equal to 1 by 30. So we get 1 by Q1 is equal to 1 by 30 minus 1 by 40, whose LCM here will be 120. So this is 4 minus 3, means 1 by 120. So finally the image, the distance of the image formed by this convex lens is, the converging lens is 120 centimeter of positive, means somewhere here at this point. So this object, this image formed by the converging lens will serve as the virtual object for the diverging lens. This image formed by converging lens will serve as a virtual object for diverging lens. Hence, for diverging lens, the object distance P2 will be this remaining distance. So this will be 120, the total distance, minus 110, and in positive. So this will be positive 120 minus 110 centimeter, we can say plus 10 centimeter, as the distance is in the direction of incident ray. That's why it has been taken as positive. And we know the focal length of this concave lens or diverging lens has been given as minus 20 centimeters. So using thin lens formula again, 1 by q2 minus 1 by p2, q2 is the distance of image from this concave lens, is equal to 1 by f2. Or we can say this 1 by q2 minus 1 by 10 is equal to 1 by minus 20. So 1 by q2 is equal to 1 by 10 minus 1 by 20. LCM is 20. 2 minus 1, 1 by 20. So finally we can say this q2 is 20 centimeter, and this is the final position of the image. So as an answer of the first part, we can write final image is at a distance of 20 centimeter to the right of diverging lens. This is the answer for the first part. Now, in the second part, we have to find the total linear magnification created. So it will be equal to the product of two linear magnifications created by the lenses. So for first one, if this is q1 by p1, for second one, this is q2 by p2. The values, putting the values here, for q1 this is 120, for p1 this was minus 40, taking the sign convention. For q2 this is 20, and for p2 this was 10. So cancelling them, solving them, we get the final linear magnification to be minus 6. And here negative sign shows that the final image is inverted. And moreover, if you want to find the size of the image, we know the linear magnification is the ratio of the height of the image to the height of the object, which is minus 6. So if we put the height of the image will be HO, which was 2 centimeter multiplied by minus 6. So HI, the height of the image, will be minus 12 centimeter. Here negative sign is showing that the final image is inverted. So this is the answer for the third part of the problem. Now again we have to repeat all these parts, but replacing the second lens. Second lens is replaced by one more converging lens having the focal length of plus 20 centimeter. So the calculation of the first part will remain same, means up to here the image formed by the first converging lens will be at 120 centimeter. The distance between the two lenses will be 110 centimeter. So we have to change the calculations only for the second lens. So, and this will become again the first part of the problem. So for the second converging lens, P2 will be again positive 120 minus 110 centimeter, or we can say plus 10 centimeter, and F2 will be plus 20 centimeter. So using the lens equation again, 1 by Q2 minus 1 by P2 is equal to 1 by F2. Putting the known values, 1 by Q2 is unknown, minus 1 by 10 is equal to 1 by 20. So here 1 by Q2 comes out to be 1 by 10 plus 1 by 20, or taking 20 as an LCM, this is 2 plus 1 or 3 by 20. So Q2, now the position of final image is 20 by 3 centimeter to the right of second lens. And then for the second part, again we will find the linear magnification M, which is M1 by M2 is equal to q1 divided by p1 multiplied by q2 divided by p2. So putting the values, again for q1 this is 120 by minus 40, but here it is q2 is 20 by 3, while p2 was the same, means 10. So calculating it, we get this is minus 10, the linear magnification. And again the negative sign associated with this linear magnification suggests us that the image, the final image, is inverted again. So these are the answers for all the parts of the given problem. Thank you.